This is day 2, adding and subtracting rational expressions. If you'll remember back to your grade school days when you were trying to add or subtract fractions, you always had to have like denominators. And to do that, you'd have to figure out your least common denominator first. So on a problem like this, and I'm just showing this as a review, the 6 you would prime factor to 2 times 3. So 2 times 3 is 6. And the 8 you would prime factor to 2 times 4, 2 times 2. So it's 2 to the third. So your least common denominator here would be 2 to the third times 3. 2 to the third because that's the highest exponent of 2 that you see as a base, and you also have a 3 to the first power. Now, whenever you go back over here, this one is missing 2 squared because it already has 2 to the first power, but it's missing 2 squared. So I'll multiply by 2 squared top and bottom, which is simply 4. The 8, since it was 2 to the third, it's missing a 3, so I'm going to multiply by 3 top and bottom, which would make this 4 over 24 plus 15 over 24, so my answer would be 19 over 24. This is a process that should be pretty familiar to you about how to find the least common denominator and such. Now, looking at expressions, what's going to happen is we are going to be including variables, obviously. So let's go ahead and do the least common denominator of these 3 items. To do that, I'll prime factor each of them. So the 15 is 3 times 5. So I'm going to rewrite this as 3 times 5 times a squared b c cubed. The 16 is going to be 2 times 8, which is 2 times 4, which is 2 times 2. So it's going to be 2 to the 4th times b to the 5th c squared. And for the 20, I'm going to have 2 times 10, which is 2 times 5. So I'm going to have 2 squared times 5, a to the 3rd, c to the 6th. Now, for my least common multiple. I go through, get each base, and get the highest power that I see for it. So the base of 2 needs to be to the 4th power right here. That takes care of the 2 squared over here. I see a base of 3 to the 1st power. I see a base of 5 to the 1st power. A needs to be to the 3rd power. B needs to be to the 5th power. And C needs to be to the 6th power. Now you could rewrite this, and what 2 to the 4th times 3 times 5 is 240, a cubed, b to the 5th, c to the 6th. Then I'd be done with least common multiple. That's a process that we'll use when we start adding and subtracting these. So when you have longer expressions, it's still the same process. You want to make a prime factorization. So that first one, I would prime factor out the x, so x times x squared minus x minus 2. And then the x squared minus x minus 2 would factor further to x minus 2 times x plus 1. Now I'm going to go over and factor this other one. It factors to x minus 2 times x minus 2, which would actually just be written as x minus 2 squared. You only want to write each base once. Now I'm ready for my least common multiple. Alright, I see a prime factor of x, only to the 1st power. I see a prime factor of x minus 2, but because of this, I'm going to make it squared. And I see a prime factor of x plus 1. And I'm done. You could multiply this out, but usually you're just going to leave it factored out. It's actually easier to work with if you do. So on this problem, I'm going to do a bit of work on figuring out my least common denominator over here to the right, so that way I can actually add the 2 fractions together. For the 6b, 6 is 2 times 3, so I'm going to rewrite it as 2 times 3 and b to the 1st. For 14, a squared b squared, I'm going to rewrite the 14 as 2 times 7, a squared b squared. Again, this is coming from doing prime factor trees. Now, I know my least common denominator is going to be 2 to the 1st power times 3 to the 1st power times 7 to the 1st power. A will need to be to the 2nd power, even though there wasn't an A over here, and B will be to the 2nd power. Okay, let's go and get this going. Over here, I see that this is missing a 7, an A to the 2nd, and it's missing a B to the 1st to make it B squared. So this tells me what I'm going to be multiplying by. I'm going to be multiplying by 7, A to the 2nd, B. in order to make it this least common denominator. I need to do that top and bottom. The one on the right, all the bases are accounted for except for 3. And so I need to multiply by 3 top and bottom, times by 3 top and bottom. Now the result is 35 a to the 4th b over 42 a squared b squared. Now the 3 that multiplied top and bottom is going to be at 27 over 42 a squared b squared. And now the denominators are alike, so I'm going to be able to combine this to 35 a to the 4th b plus 27 being divided by 42 a squared b squared. Where you'd want to go is you'd want to factor this apart any that you can and cancel out anything that you can. But this is wrapped up now. All right, here's the next problem, example 3, and what I'm going to do is go ahead and prime factor the 2x minus 4 and the 4x minus 8. And this factors to 2 times x minus 2. This factors to 4 times x minus 2. I'm actually going to rewrite the 4 as a 2 squared. So for my least common denominator, I know I need a base of 2, which is going to be squared because of this over here. And I need a prime factor of x minus 2. The only thing that's missing something is this one on the left. It's missing 2 to the first power. So I'm going to come over here and multiply by 2 to the first power, top and bottom. And that's going to make it a 2x plus 10 over 4x minus 8 minus 3x plus 8 over 4x minus 8. Now I'm ready to combine these. A step I like to do is I like to change the subtraction to the addition by changing both signs on the numerator. Now I'm ready to combine these. So I'm going to get negative x plus 2 over 4x minus 8. Now, I'm actually going to reduce this further because, like I said, if possible, you should reduce it. Because remember that the 4 could factor out on the bottom. And on the numerator, negative x plus 2 can be rewritten as x minus 2 if I factor out a negative 1. So now the x minus 2's cancel, and you're left with negative 1/4. And that wraps it up. So what's going to happen on this problem is you're going to actually go ahead and look at your denominators, which are a and b, within the bigger context of the fraction. And that means the least common denominator is AB. So in a situation like this, what I do is I multiply the numerator by the least common denominator and the denominator by it as well. That way I'm multiplying by 1. On the numerator, this ends up being really easy. 1 over A times AB, the A's would cancel and you're left with 1B. 1 over B times AB, the B's cancel and you're left with 1A. Going on to the denominator. 1 over B times AB, the B's cancel and you're left with 1A, minus 1 times AB is AB. Now try to factor anything that you can. The only thing that you could factor would be the denominator, which would make it A times 1 minus B. But I do not have any common factors that can cancel, so this was a good answer. You could actually present either answer to me. I don't really care. Usually you'll see the one where it's factored. So in this last example, same thing. You're going to see the least common denominator of AB that you're going to multiply by top and bottom, just like the last one. So the numerator, the A's cancel here, so it's going to be 3B minus the B's cancel here, so it's going to be 4A over. On this next one, the B's cancel, so you're left with 2A. Take away. Both A and B cancel here, so you're left with just 1. And you can't factor anything, so there's nothing to cancel, so you're actually done. That wraps up the lesson. Please let me know your questions. Thank you.